time to come down here despite the weather. We actually had 150 people RSVP, 80 people are on the wait list, and then they're very delicate. They can't survive a few drops of water again. So a big thank you to Christopher and his colleagues for making time to come out and speak with us. Thank you to Amazon for hosting A9, for hosting us. Just a quick word from Amazon, actually.
Hi, everyone. My name is Andrew Clark, and I would like to welcome everyone to A9. Thank you for coming tonight on this stormy evening. We're really happy to be hosting the SF Machine Learning Meetup for the first time here at A9. So thanks again. Just a little background on A9 and who we are. For those of you who may not be aware, we are a wholly owned subsidiary of Amazon. Our primary focus is conducting research and developing innovative technology for Amazon's search and advertising businesses. We are using machine learning to leverage Amazon's massive data sets to build solutions that are actually driving Amazon's retail business. We're applying machine learning and big data concepts and methodologies in the areas such as for example, such as recommendation engines, visual search, and ad and search relevance. Much of this being the technology and intelligence behind a lot of the functions that you see on the Amazon website. So we are hiring, and that's actually why I'm standing up here today. We are looking for machine learning engineers and software development engineers to join our teams. We have a lot of openings, and we're looking for great people to solve some interesting problems. So the great thing about A9 too is we're a small company environment. The individual here has the opportunity to really have a significant impact on the development of the product. So it's a great environment. Over on the desk over there, I actually left some business cards. Please feel free to take one. And please feel free to reach out. I'm happy to talk to anybody about what we're doing here at A9 and if that might align with your career goals. So thank you again for coming tonight. It's great to have you here, and enjoy the talk.
Christopher, it's all yours.
Oh, you don't need that.
Yeah. Hello. Can you hear me? I don't know, is it working?
Is it working?
I don't think so. Test?
Yeah.
It is? Okay, cool.
This has to be. Okay, should work.
All right. Hi, I'm Christopher Berner. I work at Facebook as a software engineer on the Presto team. And Dan and Martine came along with me. They also work on Presto. In fact, they started the project. So what I'm going to tell you about is Presto Ml, which is a plugin for Presto that allows you to do machine learning in SQL. Sort of the vision here was to marry the power of machine learning to the simplicity of SQL and make it frictionless to develop pipelines and prototypes of machine learning models. Okay, so my talk is divided up into about 6 pieces, and feel free to interrupt with questions at any time. It's a pretty small group. So first I'm going to just give a brief overview of Presto for those who haven't heard of it before. Then I'll talk about why I think doing machine learning in SQL makes sense, followed by a live demo, which hopefully will go flawlessly. Then I'll give some more details of how Presto ML works, more details on how Presto in general works, and then at the end talk a little bit about some future work that I hope to see done on Presto ML. All right, so what is Presto? Presto is a distributed SQL engine. But what does that mean? It means that it's sort of like MySQL or another traditional database, except running on hundreds of computers, and it's not actually responsible for the data storage. It just does the computation and processing of the queries. It was designed at Facebook as a low latency replacement for Hive. We rely heavily on Hive, and that was also built at Facebook. But when the project was started, analysts had a lot of trouble running their queries because of the latency from Hadoop and MapReduce. And so we built Presto, which is ANSI SQL, similar to H2L, which is what Hive uses, but not quite the same, and more standards compliant. And also it has a very extensible connector system. This is how Presto ML works. You can load completely new functions, new types, and you can also connect external data sources to Presto. So not only can you query data in Hive and Hadoop, but you can also query your data in MySQL or in any proprietary data store. I'll talk a little bit more about that later.
Is that available in Apache open source?
Yeah, so Presto is completely open source. It's not an Apache project, but there are connectors for all of the major Hive versions, as well as MySQL, Postgres, Cassandra, Kafka, probably a couple others that I forgot. But yes, we ship a bunch of connectors.
And it's Apache licensed.
It is Apache licensed, yes. Okay, so why does it make sense to do machine learning in SQL? Before joining the Presto team, I worked on the newsfeed ranking team, and prior to that, did a bunch of other machine learning work. And so I've built a number of machine learning pipelines and worked on other people's pipelines, and I've noticed that most of them go something like this. You've got your data in your database, maybe some other proprietary systems, and so the first step is getting all the data out. So you write some custom connectors for your data stores, you dump some of it to disk, you transform it into a nice normalized format and extract all the features you want to use, and then you can finally get to building a model and doing machine learning, at which point you write a custom binary in C++ or maybe Python or Java. Then you do your training, and then of course you have to build a service so that you can serve all your predictions. So this takes a lot of time, and most of it is spent extracting data, doing ETL and feature engineering, and very little of it is spent on the actual training of models. So what if instead you could just write some SQL? So quick show of hands, how many people are not familiar with SQL? Okay, cool, everyone knows SQL. That's awesome. So in Presto, you could write something like this. You could write 4 lines of SQL that create a new table containing a model that you train using this custom function, the learn classifier function. That's what is provided by Presto ML. And it selects all your data from a table that's already available because Presto connects to your database, it connects to Hive, connects to whatever other data sources you have. And then you can simply train a model by calling the function that's been installed via the Presto ML plugin. So right now, the plugin ships with basically just a wrapper around libsvm, and it allows you to create classifiers as well as regression models. And the interface is as simple as possible because I think there are a couple audiences that might want to use this. So as a software engineer, I'd use it for building prototypes. Maybe I'd use it to build an entire pipeline, if I could do that. But also, people who are not engineers could use this. We have a lot of analysts at Facebook, people that know statistics, know all of the data in our Hive warehouse, in the databases that I'm working with. In fact, when I was building the last pipeline I worked on, I worked closely with them to find out where we would be able to get different features from. But of course, they couldn't do any of the actual engineering work because it was all in Python or C++. But I think by moving things into SQL, it would open up the tools to a completely new audience. You can have your analysts building models and building prototypes. Oh, another great thing about this, because it's connected to data stores, you don't need to worry about losing models. I don't know about you guys, but I've worked on projects where someone builds a model on their laptop or on a development server, and then 6 months later you're like, oh, hey, where's that model? We want to make some more predictions. And then there's a scramble to try to find out if it still exists. In this case, you just create a table, store it back in HDFS, and you don't need to worry about it disappearing. All right, so let's do a demo. So I've got a couple tables here. So I've imported Fisher's Iris dataset, a classic. I'll show you a couple rows from that table. So pretty simple. I added a training column just to split the data up into some training and validation data. Then you've got the class as well as the features. So then I made another table. And this just has a couple of different settings for libsvm, because we're going to do an example of doing a little bit of hyperparameter tuning. All right, so how does this all work? Where are my examples? Okay. Formatting is a little bit more, and this is probably too small. Can everyone read this? How about like that? Is that big enough?
Yeah.
Okay. All right, so what this query does is it has a create or replace view, creates a view called trained models, and in those trained models, it creates a SVM classifier like I showed you earlier. It then does a cross join with the hyperparameters table, and that allows it to train one model for each set of hyperparameters. So let me show you how prediction works. All right, so we've got a very simple SQL query, and it just predicts the true class, or shows the true class, and then predicts the predicted class. And this is all done using this one SQL function here, the classify function. So classify, unsurprisingly, takes the features in the model, and it just makes a prediction. And you can use it in whatever kind of SQL query you want. It's a normal function. So now let's look at another example. So in this example, let's see if I can format this a little bit better so you can read it. All right. So what we have here is we select the parameter setting, and then we have count if class equals classify. So class equals classify is going to be true if the predicted class is the same as the true class. And then count if just counts all the instances that are true. And then at the end, we group by the parameters. So this is the hyperparameters that we use to train the model. And then we have order by 2. So we just sort them in order of which model was the best. And we can see this tells us that the linear kernel was the best. It got 29 out of, I think I made 30 validation examples. So it got 29 of them correct. The other 3 all got 10 correct. Sort of just a toy example. But you can see it's very easy to just test out a bunch of hyperparameters. I could have filled my table with hundreds of hyperparameters, and because Presto is distributed, it would have separated the work across the entire cluster, and you could have very quickly tested a large number of models. I'll show one more example. So I added this evaluate classifier prediction function. And it takes the true class and the predicted class and sort of just makes a report that's easy to read. It's mainly for people who are non-programmers. And so it tells you that this model had an accuracy of 96%, got 29 out of 30 correct. And then for each class, it tells you what the precision and recall was. So you can see that for Versacolor, it had 1 mistake, so the precision's only 90%. And for Virginica, it had another mistake. Didn't quite get 100% recall. All right, let's go back to the presentation. There we go. All right, so Presto Ml is simply a Presto plugin. Like I mentioned before, plugins can provide new functions and new types. So it just works like any other Presto plugin would. And it provides classification and regression, which is powered by libsvm. Something I'd like to add to it is a lot more feature extraction. I think that would make it much easier to use for people who are non-programmers, especially if you wanted to extract features from text or images or something like that.
Is Presto ML code also open source?
It is, yep. All of it's open source. Okay, so the way that this works is you've got your SQL query, and it goes to the Presto engine where it gets parsed and analyzed and then planned. And so during that process, the ML plugin participates, or the functions that are provided participate in the planning. I don't know why my slides don't advance sometimes, but there we go. So after it's been parsed, Presto comes up with a logical plan. So the logical plan is going to be something like a table scan, followed by, in this case, a grouped aggregation. And so you can see here, this is very similar to the first query that I showed you, except now we're going to train one model for each user, which is as easy as adding a group by user, and then we include the user in our select clause. And then at the end, of course, we create the table. And since Presto is a distributed SQL engine, we have to then convert the logical plan into a distributed plan. And so during distributed planning, you can see that things map mostly one-to-one. The table scan is still a table scan, but now it's running on hundreds of nodes potentially. The aggregation is then processed in a second stage. And between these two, we have to shuffle the data because every user's data needs to end up on the same machine to process the aggregation. After that, you write it to a table, and then finally a single machine processes the commit so that it's atomic. One thing to note is that if your data store was sharded by the user ID, you could actually collapse these two into the same stage, and the Presto planner would do that for you. It would say that since the table scan is already sharded on user ID, and the aggregation needs it sharded on user ID, then you can just merge them together. So Presto, like I mentioned before, is actually I don't think I mentioned it was in memory, but we do all of our processing in memory. This is to reduce latency, because it's primarily designed for low latency interactive queries. This makes it more similar to Spark or Impala than it does to MapReduce or Hive. All of our execution is done using a DAG, where processing is sent through every operator in a pipeline. So in MapReduce, you would wait for everything in your first stage to finish before beginning the second stage, whereas in Presto, we read in pages, and they're moved along the pipeline as each page finishes its processing. It also uses a bunch of specialized SQL operators. This keeps processing efficient, and we also make a bunch of optimizations on the worker machines, which I'll talk about a little bit more in a moment, such as generating bytecode out of SQL expressions so that they execute quickly. And then we do adaptive scheduling so that slow workers don't slow down the entire query. If one worker is running slowly, we'll move work over to a different one. All right, so here's how the connectors work in Presto, as well as a little bit more about the architecture in general. Presto has a coordinator, or potentially you can run it with multiple coordinators. But the coordinator's responsibility is basically accepting queries, parsing them, analyzing them, planning them. And that was what you just saw earlier. And during that process, it interacts with the connectors that are installed using the metadata API and the data location API. So the metadata API is used for discovering tables, resolving the types of the tables, but also for functions, like the machine learning functions. The data location API is used for locating the actual data. So if your data is in Hadoop, then it would talk to the name node. If it's in MySQL, it would use, well, I guess we have an internal sharded MySQL plugin, but we haven't open sourced that yet, but it would discover which shard the data was on. Once that's done, the scheduler schedules work and assigns every task to a worker machine, which then uses the data stream API to actually pull the data out. And I think the next slide shows a little bit more about how this works. So you have a client submitting data to the coordinator, which then schedules one or more stages. And so the first set of workers usually is just pulling in data, and then they're sent to a second stage or possibly even more stages. And so that's where all of the aggregations will be processed, machine learning models will be built, or data written out to tables. You guys have any questions? Been quite quiet so far. Alright, so a little bit about some future things that could be added. This is a very, very early project. I built it during a hackathon that we had at work, and then polished it up over a couple more days. But it's not something that I work on full time. So it's very, very early. Obviously, more models would be a great thing to add. It only supports support vector machines at the moment through libSVM. And then feature extraction. Obviously, this is huge for non-programmers because they're probably not going to be able to do it themselves. And the hyperparameter tuning is already possible because you can do a cross join with some other table and then train a bunch of models and filter them out yourself. But I think it'd be pretty easy to provide some functions that just did it automatically. You can provide your set of training data, your table of hyperparameters, and it could just pick one for you. You could even have it test out multiple different types of models so that it wasn't restricted just to SVMs. You could try other ones too. Feature selection, obviously, because we've got a distributed execution engine with lots and lots of cores. It would be very easy to try out tons and tons of different features and pick the best ones. And then other use cases. Right now, it only does classification and regression. So there's no support for learning clusterings or collaborative filtering, but those would be pretty easy to add too. The core Presto engine might need a few changes to make this work. So one of the limitations is that all of the models that are built in Presto ML need to be trained on a single machine. We don't do any distributed training right now. And that's probably something that you would want to do if you wanted to train a really large model or do some sort of really large collaborative filtering problem. But I think all of that's relatively easy to add into the Presto engine. It just takes a bit of work. Yeah, I've been noticing other people in the industry looking at similar areas. I know the Spark people are working on MLlib and working on ML pipelines. It's kind of a similar idea of trying to make all of this a lot easier to use and more maintainable. Yeah. More questions? Yes?
How quickly can I visualize the data? Like, what do I feel like ideally I want an IPython notebook instead of a web interface. Just type in some command and plot it right away. But so right now it seems like I have to transfer this data into somewhere else to do any plotting.
Yeah, so I guess one thing with IPython Notebook is, so we actually have a Python client for Presto, where IPython Notebook could potentially just be driving these queries, so you could have all your data stored in Presto. And then IPython Notebook could submit queries, all the data could stay inside Presto. And then, I guess for doing plotting, depending on what you wanted to plot, you could just get back the results that you wanted to plot. And this would save you from having to store all of your raw feature data and process it in Python. So yeah, I think you could easily do that kind of plot.
Is there a time frame for this?
Is there a time frame for this? As soon as you implement it. Yeah, like I said, this is not what I work on full time. I sort of built it in a hackathon, and then when I have spare time, I add new features. But it's all open source, and I would love to have people contribute to it.
So ODBC, JDBC as well, right? So we use Tableau against this, and we visualize the data in Tableau.
Yep. Yeah, so that slide that I showed you with a client talking to the Presto coordinator, that can be through a REST interface, it can be through JDBC, ODBC, There are a lot of options for talking to Presto.
You can also write the data back to MySQL and use a traditional tool.
Yep, you can totally do that. Yeah.
How easy would it be to write your own model with say the linear phase instead of SQL? It's hard to see what's the code.
Yeah, actually. I don't think would be very hard at all. I have the code on my laptop, and we can look at it. Look at the.
Bring the resolution down.
Oh wow, that's really small. Okay, let's see. Let's see if this works. That's much better.
Another view, there's a presenters mode.
That was it. Yeah, that's pretty cool. All right, so this is how I implemented the SVM classifier. It just extends a abstract class, and then down here it has a couple of methods that just call into the SVM library. So you have the classify function, and it just calls right into SVM predict. So if you wanted to implement naive Bayes, it's as simple as implementing this interface classifier. And then the other thing that you need to implement is the serialization and deserialization of the model, because these need to be transferred across network connections potentially, since your worker is running on different machines, and also this way you can write it back to the database. But yeah, so you can see here I just delegated to the SVM load model function. And similarly, there is a serialize function. Where is the serialize function? Maybe it's here. Oh yeah, get serialized data. And so you can see in get serialized data, it also just calls SVM save model. So as long as we can serialize and deserialize from a byte array, very easy to implement.
What's an SVM model? Is that like a standard library, or is that like your own custom one?
Oh, libSVM. Yeah, it's an open source one, and I've forgotten who developed it.
CJ.
Yes. But yeah, so they have a Java part of it. I just imported that. Yeah.
So do you have any benchmarks comparing, say, Spark with Fluent?
For machine learning specifically, or?
For machine learning.
Not for machine learning specifically. Yeah, because I haven't invested a lot of time in this, I haven't gotten to benchmarking. I think that their implementation is probably much more mature. This is something that I wrote in. I probably invested a week or two total. It's more designed for making it interesting for people who are non-programmers. But no, we haven't done any benchmarks of the machine learning itself. The execution engine and SQL processing, we've done a bunch of benchmarks with Dangit actually. I don't think we did anything against Spark in particular, but we tested against Impala, and very similar performance. So I would assume the same is true for Spark.
Cool. Thank you.
All right.
Is your work software engineering or machine learning side?
I mean, we don't actually have a big distinction between the people that do machine learning and the people that do software engineering. But right now I'm doing more systems work. I work on the core of Presto. But in the past I did a bunch of machine learning, which is sort of why I decided to build this for a hackathon. It actually came out of a project I did where we used Hive to do a bunch of our machine learning. We would build models, load them into Hive, and then make predictions inside Hive, write them back to HDFS. And I realized this could all be done way more simply by doing the training in Presto. Cool. Well, I'll hang around if anyone wants to see code examples or just ask questions.
We have a lot of pizza that needs finishing, so feel free to take it home if you want.